Hello everyone. Today we're taking a look at the paper Efficient Training of Language Models to Fill in the Middle by a bunch of authors from OpenAI. The link is here in the description to the paper. This paper is about large-scale language models. So following the introduction of the transformer architecture by Vaswani et al. In 2017, large language models trained on diverse internet-scale datasets have achieved remarkable success. They are capable of producing coherent and sensible completions most of the time, given a natural language prompt, and they achieve state-of-the-art performance on many benchmarks, including reading comprehension, question answering, logical inference, and common sense reasoning. There are several broad classes of transformer-based language models which are here on the slide. First, you have encoder-only models like BERT that are trained with a masked language modeling objective. Given some text, a small percentage of tokens in a text are replaced using a special mask token, and the task of a language model is to predict the most likely word that goes in the place where the mask token is supposed to be, which in this case is very. Another class of language models is encoder-decoder models like T5 that are trained typically with a span prediction objective. I have done a video on T5 in the past, I believe, but basically it's an encoder-decoder model where you input text prompts like this to the encoder, and you're supposed to do some sort of a reasoning on that and generate something using the decoder network. And then a final class of language models are causal decoder-based language models, such as GPT-3, 2, and so on and so forth, that are trained using left to right next token prediction objective. So given a prompt such as the students open their blank, the goal of the language model is to output the most likely next word. For example, books, laptops, exams, minds, and not something that is very unlikely. Here you have a lot of different language models. It has been a very popular area in the last few years, especially for training super large language models. So for example, you have GPT-3, Codex, which is trained on code, and a bunch of other ones which you can check out here. And I just made the video about the Bloom language model. You can check the last video to learn about that one. So casual language models have a limitation, most notably that they can only be conditioned on a prefix, not on a suffix. So given some prefix, which this is the prefix here, you generate some text, some suffix. This is limiting because there are many potential use cases where conditioning on a suffix might be very useful. For example, in code completion, maybe you want to give a suggestion to the user for import statements that should be added to the top of the file. And this is a limitation which the current paper we are looking at today is trying to address. So the goal of the paper is to equip or to allow causal language models to be able to fill in the middle. So what does that mean? Here I have an example code. This is like a function. And for example, fill in the middle could be to generate this span that has been highlighted here, and only that one. Whereas filling in a standard way, like in a causal autoregressive way, would be given the function up to here, predicting the next lines of the function. Whereas now we are trying to use both the prefix here and the suffix to predict the middle. That is what the paper is trying to do. Here we have another example. Here it's natural language, where perhaps you want to generate some text that again matches not only the prefix but also a suffix. And this is actually, it turns out, based on what they're talking about in the paper, it seems that this is a more difficult problem versus standard autoregressive language modeling, because basically you have a more constrained situation. So in standard case, what you generate after a prefix is kind of open-ended, so it doesn't really matter. There's less constraints. But if you have a suffix that you need to match, it's much more difficult because what's in the middle has to match not only the beginning but the end, if that makes sense. So it has to make sense as a whole. So this is much more difficult. And here we have, I think this is an example that was successful using a model that was created in the paper, where this example makes sense, but this one doesn't make sense. It shows like a difficult case where here the model generated, I would often skip classes and go to, and that's how first I got interested in AI research. And actually this doesn't make sense. It doesn't really fit in anymore in the content. So what are some of the key findings of this paper? So the authors train language models, standard autoregressive language models, to fill in the middle. What they do is they modify a small amount of the training data set, which they use to train autoregressive models, to make it work for this fill in the middle. So given a document which can be broken down into prefix, middle, and suffix, they swap it around and such that it becomes prefix, suffix, and middle. So they put the middle, like they choose a middle segment, which could be just a few words, it could be a sentence or multiple sentences, and they move this to the end. And then what they try to do is, given a prefix and a suffix, they try to predict the middle. To make this work, they introduce special tokens to help the model, guide the model to know when it has to generate the middle. So they have a special pre-token where they have the prefix, then they have a suffix token to signify when the prefix has finished and now we have the suffix. And then you have a special MID middle token where the middle comes in. And this is how it's done during training. They prepare a small portion of the data set like this, prefix, suffix, middle, and given prefix and suffix, they predict the middle, or they just train like this. And during inference, what they do to use these models is they prepare a prefix and a suffix, and then they put the middle token, and then they generate a middle. So that's how this is used. And what they do, once they have this data set, they train the autoregressive language model on both fill in the middle benchmark, or using both fill in the middle data and standard left to right generation. And they try with different proportions of this. So let's say only 10% of the data set is fill in the middle and 90% is standard autoregressive generation. And then they try increasing up to 90% fill in the middle, I believe, to try to find what is a good balance. And how does the model take this? Is the model able to learn both objectives or not? And how to train a model that is able to do this, fill in the middle, to pre-train a model. And it turns out that it's able to do this. So it seems that training language models to fill in the middle doesn't really affect autoregressive performance. So you can train a large language model on both tasks, and you get fill in the middle for free. And for autoregressive, seems to work just as well. So this is one of the key findings of the current paper. So you might as well use a model pre-trained also on fill in the middle, or might pre-train a large language model, because then you could use it for more things than the standard autoregressive model potential. Another takeaway is that pre-training a language model on fill in the middle is more effective than fine-tuning an existing language model on fill in the middle. So if you just take let's say a GPT-3, let's say it doesn't have to be the biggest one, let's say, I don't know, 5 billion, and you fine-tune that one on fill in the middle, it seems that one will perform worse than taking a pre-trained large language model using a train on fill in the middle. So it really seems to be beneficial to use this pre-trained fill in the middle model if you're interested in that task, rather than fine-tuning an autoregressive model on this task. So that is interesting. And so this is and in the final takeaway, it's more like analysis. What they do in the paper is they do a detailed comparison of different ways to pick the middle element, as I said earlier, so from just a few words, a few tokens, to one sentence, multiple sentences, as well as comparing different ratios of fill in the middle elements to normal autoregressive elements in the dataset to find the best trade-off. And the best trade-off, from what I recall, seems to be that 50-50 is very good. 50-50 fill in the middle and normal. And I think it was one sentence, but I'm forgetting now if I believe it was one sentence is the best one. But those are the main things that I wanted to cover for this paper. And overall, it is an interesting way, an effective way to allow language models to generate in the middle. I didn't actually find a lot of comparisons with other potential models in the paper. So could you, I don't know, for example, scale BERT to fill in the middle? Why not do that versus training an autoregressive language model? I didn't really find that, but it could be in there. I'm not sure. It's a pretty long paper, something to check out. And that's pretty much it. Thanks for listening, and I will talk to you in the next one.